All right, so in this video, we're going to look at some of the common acid-base reactions. And there are some, patterns that we see that if you have certain types of bases or certain types of acids, then you could expect that certain products are made. All right. And so we'll go through about 3 different types where if you notice that you have a certain type of reactant that are either acid or base, then you could easily predict most likely what are going to be the products. Okay, so the first one I'm going to talk about is a reaction of acids with hydroxide ions. Okay, and so anytime that you have something like this, you'll typically yield water and salt. All right, and to be a little bit more specific, if you have one equivalent of your acid, all right, which reacts with one equivalent, to be specific, of a metal hydroxide. Okay, so it's a cation that's attached to a hydroxide ion. You'll typically make H2O and a salt. Okay, and so let me give you an example of how this looks like. All right, so like for example, if you had HCl, so this is your acid component. All right, and it reacts with let's say potassium hydroxide. All right, that's your base component. Here's the hydroxide, here's the metal, so a metal hydroxide. What you're going to produce is that you're going to have water, all right, plus you're going to create your salt. Now remember, salt is really just the ionic compound. So because here's the cation, here's the metal, all right, this potassium, and here's the non-metal chloride. All right, so this is your salt here. That's your water. And so this is typically of a reaction of an acid and a hydroxide. All right, so let's look at one more example of such. So let's just say we have hydrochloric acid, and it reacts with magnesium hydroxide. Okay, now with these, you always want to make sure that when you're predicting the products, that you first try to realize what type of acid-base reaction we're dealing with here. So this is an acid reacting with a metal hydroxide, so we know we're going to make water particularly, and an ionic compound. Now, ionic compounds always consist of the metal and the non-metal of the acid and the metal of the base, so magnesium and the chlorine. We always make sure we consider our charges to have the correct formula, and then after that you have to make sure you balance this. All right, and so once you balance this correctly, then this will be a good reaction here. So this will be the reaction when it's balanced correctly. Okay, so this is just another example of an acid reacting with a metal hydroxide. All right, so let's look into the reaction of acids with bicarbonates, which is HCO3, -1 charge, or carbonate ion, which is a CO3, -2 charge. Okay, now both of these act like bases, so that means they will actually receive the hydrogen ion. Now, for bicarbonates, all right, it will take in 1 hydrogen ion to form, and there's a reason why I'm writing it this way. All right, to form carbonic acid. All right, so this is an aqueous solution. All right, and then for carbonate, it will actually take 2 hydrogen ions to form essentially the same substance. All right, so bicarbonate would take in 1 hydrogen ion, because there's really 1 hydrogen in the there's already 1 hydrogen here. All right, so to become a complete neutral, it needs 1 more hydrogen ion, while carbonate, all right, will take in 2 hydrogen ions to become carbonic acid. All right, now the thing is about carbonic acid it's a very it's a very unstable molecule. And so what's going to happen very quickly, all right, this is going to become, obviously with other substances, but this will become H2O liquid plus carbon dioxide gas. Okay, so this is always the output of this. And this is a reaction that you guys probably seen before when you consider the volcano reaction, right? And with the volcano reaction, this is a typical, science experiment that you find with little kids, where you take vinegar, all right, and you mix it with baking soda. Now, baking soda is sodium bicarbonate, all right. Vinegar is your acid, all right. So it's going to donate the hydrogen ions to specifically the bicarbonate, all right. And then what you'll see is like this, all this foaming and gas, and the foaming that you see is carbon dioxide. And so it makes carbonic acid, but then the carbonic acid quickly decomposes to water and carbon dioxide. All right, so just to kind of give you some context, or just like a real life example of what's going on here. So we could use this, and if we know what substance we're dealing with, then we know exactly what the products of the reaction is. So for example, let's say we have nitric acid, which is reacting to some carbonate compound, but we're just going to look at the carbonate ion. Okay, what is the product? What products are we going to make? So what we know, definitely we're going to make H2O. All right, we're going to make carbon dioxide, and then we have some nitrates left over, and so we're going to have some nitrate ion within the solutions as well. So these are going to be the products of this reaction. And then, of course, we cannot forget to balance the chemical equation. So by adding the 2 in front of the nitric acid and the 2 at the end of the nitrates, then we have ourselves a balanced chemical equation. So the last thing we're going to talk about is reactions of acids with nitrogen-containing compounds. All right, and so let's just jump into it. So let's talk about the reaction of ammonia with hydrochloric acid. Okay, so now what's going to happen? It's going to create. So ammonia is going to be your base here, and so it's going to take in the hydrogen, all right, from the acid, and what you're going to have is an ammonium ion plus your chloride ion. Okay, and so these are going to be aqueous solutions, or actually, if they're going to be aqueous solutions, then we could just write them together. Just know that, remember, aqueous solutions, they're separated. So you have an ammonium chloride solution, which it's soluble, right? All ammoniums are soluble. All right, and so if you were to write out the Lewis structure, all right, here's ammonium, right, and then here's your hydrochloric acid, and what happens is that this ammonium is going to take in this hydrogen, all right, and so then it's going to look like where we have now the ammonium ion, NH4, okay, and then you have this chloride ion that, this is a +1, I'm sorry, and this is a -1. All right, and so typically you will have something that looks like this. All right, and this is usually typically the case with your nitrogen containing bases, where it would accept the hydrogen and becomes oftentimes something that's very soluble. All right, and so like here's another example. So here's another example, right? We have methylamine, which reacts with hydrochloric acid. So I'm going to draw the Lewis structure so we can see what's going on here. So here is the Lewis structure of methylamine. All right, so it's a nitrogen-based nitrogen-based compounds, and amines are basically an organic nitrogen-based compounds, often found in bodies and often found in living substances, and they do all sorts of neat things in the body. All right, and then we have your hydrochloric acid here. All right, and so because this is a base, it's going to accept the hydrogen from the acid. All right, so and specifically the hydrogen is going to go in here. All right, this is where the hydrogen is going to go. All right, and so when that's the case, all right, what we're going to have now, we have methylammonium ion. So the methylammonium ion looks like, now we're just with that new H attached, and I'm going to highlight this new H here. Here's your new H attached. And then we have the chloride ion, which is now kind of by itself. Oh yeah, and this has a charge as well. All right, and so this is basically how nitrogen-based compounds, overall structure of how it takes the hydrogen from the acid, and ultimately these are the type of products they make.